Okay, so we've got a relation is a mapping or pairing of input values with output values. The set of input values is the domain, and the set of output values is the range. No, we'll just have to deal with it. Okay, so you can represent a relation in at least 4 ways. Ordered pairs, a table of values, you can plot them on a graph, and you can use a mapping diagram. And you should remember this from Algebra 1. This should not be anything really new. One thing I would like you to write in the little space beside example 1 is another way to think of domain are the x values, and the range are the y values. So again, domain are input values or x values. Range are output or y values. So if we look at example 1, it says consider the relation given by the ordered pairs. Identify the domain and the range. So we're going to use the lowercase d, and the domain, you just list the x values. So this would be -2, -1, 1, 2, and 3. Very straightforward, okay? Domain are the x values. Now the range are the y values. So I'm going to put 3, 1. Now you don't put 3 again. You don't repeat numbers. Then I have a -2, and then I don't need to put the 1 again. So my range is only 3, 1, -2. It says represent the relation using a graph and a mapping diagram. So let's start with the graph. And what I'm going to do, when I do a graph, and this is just in general, look at your largest x value. My largest x value is 3, so I'm going to go to the right 3 and the left 3. I also look at my largest y value, and I mean that by positive or negative, and there's a 3 for the y value, so I'll go up 3 and down 3. So what I'm going to do is a relation is just a set of ordered pairs. So I'm going to plot -2, 3, -1, 1, 1, 3, 2, -2, and 3, 1. A relation is a set of ordered pairs. The domain are the x values, the range are the y values. Now a mapping diagram, these are kind of fun to do. A mapping diagram is where you make like 2 ovals. And we'll call the first oval the input and the second the output. And so what you do is you put the domain in the input oval, and you put the range in the output oval. So I'm going to put -2, -1, 1, 2, and 3. And then in my output, I put 3, 1, -2. Now what you have to do is a relation is a set of ordered pairs. So I draw an arrow going from -2 to the 3, -1 to 1, 1 to 3, 2 to -2, and 3 to 1. Do you guys remember this from Algebra 1? Is it coming back to you? Super. All right, so again, a relation is a set of ordered pairs. Domain are the x values, range are the y values. A function is a relation for which each input has exactly one output. If any input in the relation has more than one output, the relation is not a function. So let's look at this letter B up here. Do you see that every input only has one arrow coming out of it? So this one is a function. Okay? Now, example 2. Go ahead and draw the two mapping bubbles. Okay? Go ahead and draw those. And then the question I have for you is to tell whether the relation is a function and explain. I do feel that I'm very transparent as a teacher. There is going to be a quiz on Wednesday. If you follow that blue assignment sheet, that's day by day, okay? So you know when all your quizzes and all your tests are. There's never a surprise. So Wednesday we have a quiz, and one of the quiz questions says, tell whether the relation is a function and explain. So it's very important that you understand why it is a function. So letter A, is this one a function? Yes. How do you know? Yeah, Henry?
Because all the inputs only have one.
Yeah. Each input has exactly one output. And that's how you should explain it on the quiz, okay? You're going to say yes because each input has exactly one output. That demonstrates you understand the definition of a function. All right, how about letter B? Is this one, Carmel?
No, because one has more than one output.
Excellent, and I like that. No, because one has two outputs. Okay? All right, questions on a function. A function, each input has exactly one output. All right, vertical line test. A relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. So this one is a function because it would pass. And I forget what I had there. This one's not a function because it crosses more than once. So in example 3, let's draw the following pictures. And actually I want to make a letter D here to talk about a special case. So I'll give you a moment to draw those and then use the vertical line test to determine whether the relation is a function. If you have your graphing calculator with you, you're going to need to take that out in a moment, so find it. Alright, let's look at letter A. Megan, do you think using the vertical line test, is that a function?
No.
No? Why not?
Because there's more, it intersects at more than one point.
Okay, can you describe where it's intersecting more than once when I draw a vertical line? Like where could I draw the vertical line? Like if I draw it here, it only hit once. If I draw it there, it hit only once. Where do you see that it hits more than once?
Oh yes, on that x-axis.
Where?
The line.
I'm not seeing it. This is the curve, right? So where can I draw? I'm not seeing it. Can you?
Oh, it is function.
Yeah, this one actually is. I mean, like everywhere I draw a vertical line, it's only hitting it once. So this one's a yes, okay? This one's a yes. All right, Hannah, what do you think about letter B? If I draw a vertical line, is it a function? No, why not? Good, it's going to hit it 2 times. Okay? All right, McKenna, what do you think about letter C?
It is a function.
Yes. All right, then Andrew, what do you think about D? No, why not? You're right. It's hitting many points. It's actually hitting infinitely many points. So this was a special case where a vertical line will never be a function, okay? All right, example 4. Recall y equals mx plus b. You remember that's the slope-intercept form of a line. M is the slope, and b is the y-intercept. To graph a line, and you should recognize y equals mx plus b as a line, what you do is you plot the y-intercept, then use the slope to plot a second point. So this is just a helpful note for you as you are looking at your notes to help you on your homework. And remember, grade your homework, and it's in the back of the book. All right, so what is, Jasmine, what's the slope here in this equation?
The slope is -2.
Good. And Carmel, what's the y-intercept?
-1.
Good. Okay. So let's go ahead and make a grid on here. So I'm going to plot the y-intercept, and then remember, slope is rise over the run. So I'm going to go down to right 1, down to right 1. And then you'll just draw a line through that. Okay? All right, so y equals mx plus b is the slope-intercept form of a line. Also, remember back to Algebra 1, y equals mx plus b, we could use function notation and say that's f of x equals mx plus b. So in example 5, it says tell whether the function is linear. So in letter A, Noah, is that one linear?
Yeah.
Okay, why? How do you know it's linear? What makes it linear?
Can be written in y.
Okay, it can be written in y equals mx plus b. Okay, how can I write that y equals mx plus b? There's a problem here, isn't there? What's the problem? Well, f of x is y, that's okay, but where's the problem, Noah?
Variable with
This x squared, so it's actually not, okay? It's not. And Elena, how about b?
Yes.
Yes. Okay, then it says evaluate the function when x is -4. So let's look at f of -4, and what that means is it means everywhere you see the x, we're going to replace it with a -4. Okay, when it says evaluate f of x when x is -4, that means everywhere you see x, you replace it with -4. Now remember, our day 1, we reviewed, please excuse my dear Aunt Sally. So I'm going to do my exponent first. So I do want you to know I am never ever torturing you with useless stuff. Everything we go over, we need to use it, okay? So I'm really trying to build you up, help you out, so that you can be more successful on the next thing that we need. So I got -1. Let's go ahead and do it over here. G of -4, that's 5 times -4 plus 8. So I'm getting -12, okay? But A is not linear because it has an x squared. B is because it's y equals mx plus b. All right, domain in real life. Example 6 says a diver using a diver propulsion vehicle descends to a depth of 130 feet. The pressure P in atmospheres on the diver is given by P of D equals 1 plus 0.03 D, where D is the depth in feet. Graph it on your graphing calculator and determine a reasonable domain and range. Well, what we're going to do is we're going to make it f of x equals 1 plus 0.03x. If you have your calculators, what I need you to do, okay, you have your calculators, let's open them up, turn them on. In the upper left-hand corner is a y equals button. So when I say go to your y screen, that's where I want you to go. So go ahead and press it. Now, if you don't have the newest kind, yours probably doesn't have all the pretty colors that mine does. But here's what I want you to do. We're going to press 1 plus point, the point's down here, 0, 3, and then here's the variable button. This one right here that says x, comma, t, comma, theta. So do you now see 1 plus 0.03x on your screen? Now the next thing I want you to do is I want you to the top row, there's a zoom button. Press zoom. Number 6 is the standard screen. Now 1 plus 0.03x is a line. Why is it so flat? What? Yeah, it's the y equals. The y's there. But why would the line be so flat? Think about y equals mx plus b. What's m here?
Oh,
0.03 is pretty, that's 3 over 100, right? 0.03 is 3 over 100, that's itty bitty. So, let me go back here. Now, domain is what could you plug in for the variable? D is the depth and P is the pressure at that depth, okay? So, the domain for D, this propulsion vehicle can only go down 130 feet. So the domain is 0 to 130. Now the pressure, what we're going to do is we're going to do P of 0 is 1 plus 0.03 times 0, which is 1. And then the maximum pressure is at the maximum depth. And I've already done the calculation because I need to start going a little bit faster here. So my range is between 1 and 4.9, and that's in atmospheres, whatever that measurement is, okay? So the domain had a limit, and you can't have negative depth, right? In terms of, we are going down, but they're talking surface is 0 going down to 130. Okay? All right. Everybody got it? All right, we are going to do 1.2. We're going to go pretty quick here. 2.2, slope of a line, which you already wrote down, was rise over run. The algebra y2 minus y1 over x2 minus x1. And the graph was something like this, where you saw the change in y over the change in x. So in example 1, if you have a skateboard ramp that has a rise of 15 inches and a run of 54 inches, if slope is rise over the run, that's 15 over 54. You reduce it, and it's 3 goes into both numbers, so it's 5 over 18. That's pretty cute skateboard ramp, isn't it? All right, positive slope rises from left to right. Negative slope falls from left to right. A horizontal line has 0 slope. And a vertical line has slope that's undefined. Okay? So because of time, we're only going to do A and B here. In example 2, it says, without graphing, tell whether the line through the given points rises, falls, is horizontal, or is vertical. So we're going to use 1 minus 1 over 3 minus negative 5. That's 0 over 8, which is 0. So which is this? Horizontal, okay? In letter B, I would get negative 4 minus 0 over 2 minus negative 6. This is negative 4 over 8, which is negative 1/2. So it falls. Be careful. Letter D ends up being negative 7 over 0. Do not write that in an answer blank for the slope. If 0 is in the denominator, you cannot divide by 0. It's called undefined. So make sure never, ever leave negative 7 divided by 0 as your slope answer. And think about this a minute. With your special cases of horizontal and vertical, if you think of slope as rise over run, you can't rise up. There's 0 rising on a horizontal line. That's why it's 0. But vertical, what ends up happening is you start rising, and it's going out of control. And you can't ever stop. It's like you're on one of those roller coaster rides that shoots you straight up and then drops you. That's what I think of when I think of vertical line slope. Okay, parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals, like 5, negative 1/5, or 2/5, negative 5/2, something like that, okay? So we're just going to do letter A because of time. It says tell whether the lines are parallel, perpendicular, or neither. So if I do the slope of line 1, that's negative 1 minus 2 over 0 minus negative 2. That gives me negative 3 over 2. The slope of line 2 would be 3 minus negative 1 over 2 minus negative 4. That's 4/6, or 2/3. So what do you know about those two lines? Good job, they're perpendicular, and you guys are welcome to use this geometry symbol. B ends up being parallel, if you wanted to try that on your own. All right, last concept. I need to get in here. You guys got it? Awesome. All right, slope can be used to represent average rate of change, or how much one quantity changes on average relative to the change in another quantity. In example 4, it says in 1965, a giant sequoia had a diameter of 137 inches. And in 2005, the same sequoia had a diameter of 141 inches. Find the average rate of change in the diameter over time. So that's telling us we want to find the slope where its diameter, change in diameter over change in time. So the diameter went 141 to 137, and it was 2005 minus 1965. Well, that's 4 over 40, which is 1 over 10. Now, what does the 1 over 10 actually represent? Carmel?
That it grew 1 inch every 10 years.
Awesome. 1 inch every 10 years. So big idea here, slope is the same thing as average rate of change, okay? So anytime you see rate of change, you want to think slope. how. I don't know how to. Where it is. Huh. I don't know how to stop it now. Oh, there it is. Yay.